Integration by parts. Unlike U substitution, integration by parts is not a transformation, just calling names. Some function will be called some function will be called U, some will call dv. Integration by parts undoes product rule. Bless you. That was the cutest sneeze ever. Product rule. Undoes product rule. And that's why if you see two functions have no connection, that usually is product rule. So here we see connections between functions. Log and 1 over x. X squared and x. Those have connections. When you differentiate one, you get something looks like a second one. But what is connection between log and x? I don't know. Sine and e. And so on. So product of two functions that doesn't look like each other, when you differentiate something, usually is undone by integration by parts. So liatin is a genius idea. When I was learning integration by parts, I did not know liatin. Nobody taught us liatin. I think it was not known thing. I think Americans figured it out. And not all American books point it out, so now I teach it everywhere. I make sure I do. How to choose U. Whatever goes first in order, choose that to be U. Works. It's genius, because I used to guess every time. So log, if you see log, that's your best choice for U. Inverse functions, arcsine, arccosine, algebraic functions like x plus 5, trigonometric functions like sine, cosine, and the last choice should be exponential. Exponentials usually do not work, so they are the last one in order. Liatin, very convenient, would save me so much time when I was a student. I don't know why I did not know that, and we were not taught this. It's such a cool idea. So I see two functions, 4x and ln x, or you can kick 4 out, it will be x and lx. So I see that I have algebra and I have log. Whom to choose? You can choose one, see if it works or not. If you choose 4x to be u, then dv will be ln, and integrating ln requires integration by parts itself. And that's how it also gives intuition that it's not a good choice. That's why we suggested u should be log, because u, we are integrating u, and we are differentiating u when we're integrating dv. So don't choose something hard to integrate. dv is 4x dx. Again, integration by parts, it's calling names. If u is log, then everything else doesn't have a choice. That will be dv. No choice here. Now it's nice because we're differentiating log and it's simple, but we're integrating 4x and it's also simple. You don't want to integrate something complicated. So when you chose u, you differentiate it right away. Gives you 1 over x dx. Then dv is the leftover. Integrate dv to get v. It will be 4x squared over 2. And you don't write down plus c. It gets canceled out. Do we do anything with 1 and 10? No. Integration by part is not a transformation, so we don't have to touch limits of integration. Do not touch 1 and 10 for integration by parts. They just stay as they are. Visual memorization is cross product minus bottom product, or a formula uv minus integral v du. That is the formula for the integration by parts, where the original integral was u dv. I call something u, I call something dv, then I can break this integral into parts. This is where the title comes from. The name, integration by parts. Yeah, so I will show you this later. So, let's do it. Did you just yawn? Are you kidding me? This is so interesting. This is like super fun. Look at this. So ln x is u multiplied by v, 4, let's simplify v, 2x squared minus is part of the formula, minus, integral of the bottom function, so it's 2x squared times 1 over x dx. The idea of integration by parts is that the hard integral should be, hopefully, broken into two simple parts. The first part is already done. In this case, we just need to plug the numbers from 1 to 10. And the second integral, hopefully, is easier than what we had before. Let's see if it's true. ln x times 2x squared from 1 to 10 minus simplifying everything inside of the second integral and hope for the best. 2x. Nice. It's just integral of 2x. Integral of 2x is 2x squared over 2, which is just x squared. So I will have x squared bar from 1 to 10. And now I can plug 1 to 10 everywhere. Well, some people like to do that. Or you can do first calculate this part and then integrate. Some people like to integrate and then plug massively 10 everywhere and then 1 everywhere. If you plug 10 everywhere, it will be ln of 10, 2 times 10 squared minus 10 squared. Plug the top minus, plug the bottom, which is 1. ln of 1. What is ln of 1? 0. So the first term is not interesting anymore. It's 0. Minus 1 squared. Equals. I will have 200, because 100 times 2. ln of 10 minus 100 plus 1. This is 0. Whatever. I don't really care what is the number. The whole point is to practice integration by parts. Minus 99. What a weird example. What do you think about this? Integration by parts. I put one example on a test. We always put integration by parts in the final exam because you're not supposed to pass this class without knowledge of integration by parts. It's way too important. Way too important. Questions about this? Again, I can show you thousands of examples, which we can do later in the Zoom. But this is also something you should just practice. If your hand remembers how to do it, you will do it fine on the test. It's supposed to be like practical knowledge of your hand. Study says that actually we do have hands memory. Your brain freaks out on the test, but your hand is already writing x squared integral gives you x cubed over 3. And that's good. The more you do it, the better it gets. So let's practice. What should we choose? Remember, li, a, ter. The first example is t and e to the minus t. Why not to do u substitution? Why not to choose u to be minus 3t? What do you think? Because derivative of minus 3t is negative 3, not negative 3t. So this power does not match. If I put square, boom, that's u substitution. That's how interesting it is. So just a little bit off. Thus, you do u substitution. What should I choose to be u? T. I see two functions being multiplied. Linear, which is algebra. That's A. And exponential. So that's my last choice to do as exponential. So exponential will be dv, e to the minus 3t dt. So du is 1 dt. But what is v? Integrating exponential, is it hard? Well, it is extra step in this case. It has u substitution when you integrate e to the minus 3t. Copy, divide by the leading coefficient. That's my shortcut for you. And that's why shortcuts are amazing, and I like teaching them. I'm not requiring to know them. But I'm teaching them because it just saves so much time. When you integrate e to the minus 3t, copy, and then divide by the leading coefficient. And then cross product minus integral bottom product. Done. Square root of t and ln t. In previous example with u sub, we had 1 over t and ln t. Because derivative of log is 1 over input. But in this case, they don't have connection. So it is integration by parts. What do you want to choose to be u? ln. The moment you see ln, that is a good choice for u. dv is everything else. Remember, dv doesn't have a choice. dv is square root of t dt. How about 7t and sine 19t? Again, if t squared was inside, that is u substitution. But it's not. Oh. So I will have 7t and sine. 7t is multiplied by sine. Two functions have no correlation with each other. What should I choose? U? 7t. I don't know. Let's check. It's not log. It's not inverse. We have algebra and trig. Algebra is first in order. So the suggestion says try algebra. If not, then you can do the other one. But it should work. Then dv is the leftover. Sine 19t dt. Again, integrating sine 19t requires u substitution or a shortcut. U substitution shortcut says integrate sine, and you know it's minus cosine, and then divide by 19. Last two, e to the minus x and cosine have no connection until you go to complex variables. They actually do have connection in complex analysis, you will see. But meanwhile, until then, we don't know. So what should I choose, u, cosine or e? Cosine. It says if you see trig and exponential should be your last choice. It just doesn't really work well. It's a repetitive function. U will be cosine. Well, cosine is also a repetitive function. Cosine gives you sine and sine gives you cosine. So this is probably a recursive integral, which is taking too much time to put on a test. dv. And the last one, ln. See, just integrating log requires integration by parts. ln is multiplied by what? 1. So we see it as a product of two functions, log and 1. U should be log. So integral of log, any kind of log, requires integration by parts. Does it make sense what I just did? This is how you know. Questions about this? Yes.
Why couldn't you use u sub for that one or no? Because like if you make 7x plus 1, then you just have no x.
Good question. Should we use u sub? Two ways of doing it. Either you do u sub right away or you do it later over here. I think right away works better. One way works better than another way. Somehow I tend to do u sub later. That's how I was trained. But that's not a rule or anything. But I noticed in some problems doing u sub first is better. So if you perform u sub first, ln 7x plus 1 dx becomes 1 over 7 integral of ln u du. Do you see how I got that? If u is 7x plus 1, du is 7. So you divide by 7. And then from there, I perform integration by parts, choosing u to be ln, but now this u is integration by parts u, and so on, and it will work. And then you have to go back to the 7x plus 1 at the end. Don't forget to go back to the original function. Very good question. Does it make sense? Let me show you something interesting. So, integration by parts, in Russian language, it will be интегрирование по частям. Интегрирование по частям. So check it out how interesting it is. I keep mentioning that math is international language, and I will prove you that is true. Can you read this? That's integration by parts chapter in Russian language. See, you don't have to know the language to know what is going on here. You see this, and you know they're talking about integration by parts. Integral u dv is uv minus integral v du. And then they tell you this history behind it, the formulas, and so on. Moreover, let's go to what, for example, that looks pretty awesome. Okay, check this out. Come on, isn't it awesome? But it's still integration by parts. So the moment you write down the formula, people know it around the world. That's how awesome this is. Very, very, very international knowledge. Integration by parts, Taylor series, partial fraction decomposition. People do know what it is. So when you learn math, you learn the whole international language. So partial fractions Wiki. That's what I like Wikipedia for. It has collection of everything in different languages. Partial fractions. That is not what I needed. No, it is. It just starts with summations. I see. Oh yeah, it is partial fractions, but in upper levels, which we need to review as well. Partial fractions, here they are, blah, blah, blah. Oh, this one. You recognize this. We did this, P over Q, here it is. Now, if I go to any other language, it will look exactly the same. Let's try something different. Look at this, Japanese. How amazing is that? And there's no art. Seriously? Okay, well, at least you can see this. And they even call it irreducible polynomial. See, they translated irreducible polynomial. And now it's hard to go back. Okay, Italiano. Look at this. AX plus B. Oh, okay, I should not do that. Because most of my friends are foreigners, we do make fun of each other languages all the time, and it's not offensive for us. But yes. Bellissimo. Make sure you can do this on the exam. So you see, it's very cool. Math is international language, and I could go to any country and teach math in English. And you guys own English as your first language, or at least second. So you're already better than me. So you can go and do some internship in Japan just because you know math and English. Isn't it awesome? So you should think about that. Exchange programs are amazing. Fulbright scholarships are so cool. It's pretty possible to get them. Go to Europe for free. Sometimes it's 1 year in Europe, they pay for everything. Definitely consider that because being in STEM opens lots of doors. It's pretty cool.